We're supposed to be, I get the gist of it. I know what parabolas look like. They might open up, they might open down. I have some feeling of what the words are around quadratics. But I'm a little concerned that we can't do much here. It seems like you're always giving us help. You're always giving us the graph, or we have to build the graph using a table of values or something. Isn't there something better? Yes. Now we get into it and go, okay, we need some better weapons here, some algebraic weapons. And actually, all I'm going to teach you today is the reverse of the distributive property. So I'm going to reteach the distributive property, which is nice for you because you need the distributive property for your test. But I'm going to reteach this, always drawing your attention to what it would take to go backwards. Yes? And then when it's all done, we'll try and go backwards. All right? That's all. Factor algebraic expressions by dividing out the greatest common factor. What the heck does that mean? It means do the opposite of this. So the distributive property says if you've got an expression out front of a set of brackets, instead of doing BEDMAS, because BEDMAS says add what's in the brackets, instead of doing BEDMAS, you could distribute the number that's out front, and you'd get AB plus AC. That's a very fancy way of saying it with the letters. This is what you see in textbooks all the time. They write it like this, and they say A bracket B plus C is AB plus AC, and everyone gets confused by these letters, but there's nothing confusing about it. Whatever's out front just gets multiplied by both things in the brackets. Hopefully you've seen that a number of times now. Before we do it in reverse, we better make sure we've got it down pat. So, just a reminder about exponent laws though. To multiply powers with the same base, keep the same base, and add the exponents. So when you're multiplying things that are powers, we keep the base the same and add the exponents. And if you're dividing powers with the same base, keep the base the same, but subtract the exponents. This is not magic, friends. Here's why this happens. Let's say I had x cubed times x to the power of 5, and I wanted to know how to simplify that. One way to do that would be to write out all the x's. X cubed would be x, x, x. X to the power of 5 would be x, 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 5 of them. And then you're like, oh, now I've got 8 x's all multiplied together. That's x to the 8. In fact, many grade 8 and grade 9 teachers teach it like that. They make you do a whole bunch of homework. We got to write it all out until you eventually go, Mrs. Jones, can't I just add the exponents? And you go, yes. Good, you see it now. You understand. It's not magic. It's just a shortcut. Is this okay? All right. Hey, we got to do common factoring, which can be a little bit difficult if you don't have all the basics. So let's recover all the basics here. So, some practice on expanding. Here's what that fancy slide was saying. If you've got a 2 out front, you look inside the brackets, you go 4x plus 7. I can't add those. I can't do what BEDMAS asks me to do, which is do what's in the brackets. My next choice, my BEDMAS plus choice, is to take this number out front and multiply it by each term in the brackets. I pause though, because at this point that's supposed to be like, yeah, I got that. That's good. I can do that. Is it okay? Some of you awake enough that have enough strength in your neck left to nod? That was good. That's important. We really got to get that. Can it get more complicated? Yes, we could put negative numbers in. We could multiply -5 times each of those. Maybe that makes it more difficult. And you need to know your multiplying positives and negatives rules. What's a negative times a positive? Negative 30x. But you may want to rely on your calculator in situations like that because you're busy, your brain's busy trying to do distributive property. It's easy to mess stuff like that up. So watch out for that. That's how those little mistakes happen, is your brain's busy on something else. Then this, -5 times -9. Wait a minute, is that subtract 9 or is it -9? And the answer is yes. Yeah, whatever you need it to be. If I was putting it together with the 6x, I'd be subtracting. But if I'm multiplying with the -5, I think of it as a negative. No trickery, that's fine. So -5 times -9, 2 negatives become a positive in this situation, and I get plus 45. So it could be like, okay, distributive property pretty straightforward, but I need to know my positive negative rules in the middle of all that. Maybe you need to know your exponent laws in the middle of all that. Look at this one. 3x times 2x. Who's got this? Let's make sure we got this. This is key to the difficult parts of this lesson.
6x?
6x squared. Thank you. And that's how you might think it through too. Exactly how he said it might be how your brain works it through. It goes 3 times 2 is 6, x squared, because there's x times x. But the next term doesn't have x times x. Look at that. I actually just bumped into it, and it switched pages there. 3x times 5. This time I don't get x squared, because there's only one x multiplied. I'm not x times x in the middle of all that. Incidentally, our job today is to take expressions like the ones you see in red and go backwards and say, where did this come from? How did it become this? Why do we want to do that? Well, you'll see. It'll be valuable to us when we're doing quadratics to be able to go backwards in these. Okay, the toughest one I could come up with on a Tuesday. 4x squared times 3x to the fourth. Pretty easy, he says. What is it? 12x6. They are pretty easy once you get used to them. That the numbers, the coefficients just get multiplied like they always did, and the exponents get added. And then this one, so then this one's 16x5. Okay? And again, our job in just a minute will be to go from red back upwards to the black. If that seems really tough, well, I'm hoping I'm saying just the right things now to get us ready for it, to get us in the right frame of mind to be able to handle that. But do you have any questions about that? Nuh-uh, he says. All right, I like that. On my slides it says page 3 of 9. So hopefully that means we're about 1/3 the way through this lesson. If your brain is a little bit mushy on a Tuesday after a strange long weekend, with an eclipse no less. Okay, to factor natural numbers means to write it as a product. You're supposed to have done this before. It might have seemed useless at the time. Just this weird exercise you do in grade 5 and 6, factoring numbers, breaking them down into their pieces. But we need to talk about how that relates to what we're doing. So for instance, 24 could be factored many different ways. You could make 24 into 6 times 4, or 12 times 2, or 3 times 4 times 2. Maybe you could make it as 3 factors, or 2 times 2 times 2 times 3. So there's lots of ways to write 24 using its factors. When we write 24 equals 2 times 2 times 2 times 3, we say that it has been fully factored. That means we've done the best job we could. We've broke it down as far as you want. And actually, weirdly, you can get there a number of ways. You could take 24 and divide it into 6 times 4, and then take the 6 and make it into 2 times 3, and then take the 4 and make it into 2 times 2, and you get all the factors there. Often called a factor tree by elementary teachers. Yes, does this sort of ring a bell, breaking things down? But you can get there any way you want. That's a nice thing about factoring. If you broke it into 12 times 2, then you could say, okay, well, the 12 is 3 times 4, the 4 is 2 times 2, and I get all the factors that way. So no real rules here on how to get to the factors. To factor a polynomial means to break it into its multiplicative pieces. Oh, is that too fancy? Did I over fancy that statement? Break it down into things multiplied together, basically. One way to factor an algebraic expression is to look for the greatest common factor. That's what we'll be up to. So I'm going to actually, I don't do this very often on purpose. I want highlighting to really mean something. I'm going to highlight that phrase, greatest common factor, because we're really going to care about greatest common factor, the biggest factor that we can find. And that we're going to put some pressure on your mental math here, or put some pressure on your ability to use your calculator to find these greatest common factors. So, example, determine the greatest common factor. Determine the largest number that goes evenly into each term. To determine the variable portion, which makes up the greatest common factor, 2 things must be looked at. The variable or variables must be present in all terms, and the exponent on the greatest exponent you see that's common to all of them. Well, we'll get to that in a second. Let's talk about 4, 16, and 32. If we are looking for the greatest common factor, I'm back in my highlighter mode. If we're looking for the greatest common factor, we're looking for the biggest number that divides into 4, but also divides into 16, but also divides into 32. What number divides into all those? 4, he says. There was another choice. 2 divides into all these, but it's not the greatest. We'll be looking for the biggest one that divides into all these. So the greatest common factor here is 4. To which you go, it really seems like I'm going to have to rely on mental math here and look at what number goes into all of these and really do a trial and error type thing. Well, that is true. That is probably the best way to do it. But there is another way. You could make a factor tree for all of these and then find out what's common to all the factor trees. For instance, I could take 4 and go, that's made up of 2 times 2. And that's the best factoring I can do on there. Then I could take 16 and I could make that into, say, 4 times 4, which is 2 times 2, and 2 times 2. And I could take 32. And if you follow the tree all the way down, you'll find that 32 is 2, 2, 2, 2, 2. And then I ask the question, how many 2's does each factor have at least? This one has 5. This one has 4. This one has 2. They all have at least 2 2's. So common to all of them is 2 times 2. There's the greatest common factor, which is 4. So someone says, am I just using mental math to find the biggest number that divides into all of them? The answer is yes, unless you want to do factor trees for all of them. But maybe there's a mixture here that you're doing. Sometimes you're using your mental math, and sometimes you're using the factor tree type thinking. I'll tell you what I do. I start with the lowest number that I see, and I work off of that one. That's what I do. So when I see 3, 15, and 75, I go, well, 3's my first nominee. Does 3 divide into 15 and also into 75? And if you're not sure, well, you get your calculator out. You go 15 divided by 3. Oh, it divides. 75 divided by 3. Oh, it divides. So that's how I look and go, okay, well, greatest common factor for this one. I start with the biggest thing it could be, which is the lowest number I see. The lowest number is the biggest number that it could be. That's weird, right? The lowest number is the biggest number. Yeah. Oh, but we're not done here. Now it's the part about the variables. How many x's are multiplied together in all of them? All of them have at least this many. So for instance, let's say you're at the fair. I love this example. You're at the fair, and all of you friends are deciding what rides you want to go on. And you look and see how many tickets each of you has. Yes, and the first person has 1x. The second person has x times x. They've got 2 tickets. The next person has x times x times x. Well, how many rides can they all go on together? It depends on how they divide them up. I agree with that. But if you only get to keep your own tickets. How many rides can the people go on together if the first person's got 1 ticket, the second person's got 2, the third person's got 3? Oh, 1. They can only go on 1 ride because the first person's going to run out of tickets after that first ride. I know about sharing and so on. It's just supposed to be an analogy, right? Sharing is caring. Yes. If they are unkind and unwilling to share, whoops. Only 1x can be pulled out of all of these. The 3x says, I'm sorry, I know you guys have x squared and x cubed, but I've only got x. So the most we can do together is x. So again, the highest exponent you can take out of all is the lowest exponent you see. That's weird phrasing, right? All right, let's go to the toughest one I've got before we move on to actually using this. What number divides into 12, 15, and 21? Does 3 work? 3 divides into all of them. 3 is a good nominee. 3 might be the answer. I'll put it over here. 3? Is there a bigger number? 4 divides into 12. Does 4 divide into 15? No. What else? What's bigger that divides into 12? 6? Does 6 divide into 15? No. What about 12? That's what I said in the last one. Start with the lowest number and see if that's going to work. 12 doesn't divide into all of them. That's the game. Sorry, that's the best I got. is to just look at them all until you can track down this biggest number. Those of you whose mental math is strong, this will go very quickly. You'll just look at it and go, and the number will pop in your brain. You won't even know what is going on. Now, you couldn't make your factor trees, but I offer one more method before I take a question. My other method is to count by threes and see if I hit all of them. 3, 6, 9, 12, 15, 18, 21. It hits them all. No other number is going to do that it hits them all as I count by it. If I go 4, 8, 12, oh, that's good. 16, oh, it didn't hit 15. 5, 10, no, it doesn't work. Yeah, so that's another way to approach it. Question? What if you just can't find it? Break out your calculator. With some trial and error with your calculator, you'll eventually find it. Yeah, so I offer, if you really have trouble with these, I offer a systematic approach. I would start with 2 and just keep going bigger until it's clear that nothing's going to work. See, if I started with 2, I'd go, oh, 2 divides into 12, but 2 doesn't divide into 15. 2 is not a great choice. And I just systematically go through them. 3 divides into 12, because I can take my calculator and go 12 divided by 3. Yep, it worked. 15 divided by 3. Yep, it works. 21 divided by 3. Yep, it works. 3 is good. Is it the greatest one? Then I just keep going. And I try 4. Where do you stop? You stop at the lowest number you see there, which is 12 this time. The lowest number in there is where you have to stop. After practicing a few times, it should go fairly fast. Okay, x's. What's the greatest exponent of x I can pull out of all of them? This one has power 2, this one has power 1, this one has power 3. So the most I can pull out is 1. How about y's? 1 again. So you're just looking for, in the case of exponents, you might be at the moment where you're like, oh, so I'm just looking for the lowest exponent. That's the one that's going to be the common factor, and that's true. But take out the lowest exponent. Okay, that's the end of the setup. Now, the lesson actually starts. Factoring is the opposite of expanding. We've been always expanding, multiplying out these brackets. Factoring just means we're going to go the other way. We're going to undo the expanding. Factored form, I'm not exaggerating when I say factored form, is almost always superior. We'll almost always be happier with factored form. Here we go. Bang, 9 examples. 3, 6, 9 examples. And then I think there's a couple of tough ones coming, but this is the whole lesson right here. Here's my question. If you peeked on my answer sheet for your upcoming test, and I said the answer to 1A was 4n minus 10, what could the question have been? What might it have said before? What number could have been in front of the brackets? Does 4 divide into 4? Yes, 4 divides into 4. Does 4 divide into 10 evenly? No, so it wasn't 4. 2. And that's the way to do these. You're like, Ms. Todd, please tell me you've got a system here. I don't. I've got essentially what amounts to some kind of trial and error thing in your head to go, what's the biggest number that divides in? Once you have that, then I've got a system. Then I go, okay, so then what was in the brackets? If 2 was multiplied in to get 4n minus 10, what was in the brackets? 2n minus 5. And that sometimes you'll just look at it and you'll know. You won't even be able to explain it. You'll just go, I know. But what's actually happening is you take each of those terms and divide by the 2 that's out front. Let's go again. Right off the bat, let's deal with negatives. For reasons that aren't clear, I need to tell you, if there's a negative out there, take the negative with you. Okay? So what number divides into both 2 and 4? 2, but I see a negative out front, take it with you. Okay? I can't explain that very well right now. But getting the negative out the brackets, we'll be happier with the negative out of the brackets like that. So negative 2 out front. So if negative 2 was out front, what was in the brackets? I agree with the minus 2. I didn't hear what you said in the other part, so I'm just going to get the minus 2 for now. I want to tell you what she did, though. She said an answer that I don't think was right, and then she fixed it immediately. That's going to happen with common factoring. After you common factor out, then you're going to go, whoa, wait, that doesn't work. I know that negative 2 times negative 2 is positive 4. I can use my expanding to fix. So what was the first one you said? Just y. And again, these things aren't going to like happen automatically. Those of you who are used to that in math where it's just like, bang, I get the answer. That's probably not what's going to happen here. What's going to happen here is you're going to play around with it until you look at it and go, yes, that's the right thing. If I multiply that in, I get the original expression. 3x minus 3. What number? I'm really starting off with ones that hopefully are very manageable here. What number divides into both 3 and into 3? 3 divides into both 3 and into 3. Yeah. So what was in the brackets then? 1x minus 1. You can write 1x. It's not wrong to write 1x. Don't ever let anybody make fun of you if you write 1x. But lots of times you'll see it just as x. And then what was the other term? Negative 1. Or minus 1. It doesn't matter how you say that. Question? No. Go with the leading one. Whatever's out front. Yep. I know what you're saying, and it's not really clear why I'm making that choice. I'm just telling you, if there's a negative out front, take it. If there's not a negative out front, don't take it. Okay. This one, no coefficient will divide into both those. No coefficient divides into 1 and 3. But what about the x's? Is there an x that can be divided out of both of these? Yeah. So we can pull an x out. Now take a second. Let it bounce around. If the question originally was x bracket something, what was the something that was inside?
1 plus 1x.
1, I agree with. I didn't hear what he said in the second part, so I'm just going to write the 1 for now, because x times 1 is x. So you can use distribution to check. So sometimes you're going to write down the wrong thing. And then when you check with distribution, you'll see it's the right thing. And 3x, yeah, that's the other one. How did you get it, though?
I don't know.
I don't know. Yeah, sometimes you're not going to know. But you look at it and go, I know it's right, because I can see by distribution it's right. What you actually do is divide by the common factor. What's x divided by x? 1. What's 3x squared divided by x? 3x. So there's your procedure. You're dividing that common factor out. When we were doing distribution, we were multiplying by the common factor. Now we'll be dividing by it. These get progressively harder, by the way. Yeah. Is there a coefficient I can bring out? 4 and 1? No coefficient. What about y's? Yeah, I can bring out a y. Only 1, because that's the most that I see there in the first term. So then what was in the brackets?
4 minus 1.
4 minus y. And again, if you're at the point right now still where you're like, I'm not sure how I know it's the right answer, but I know it's the right answer, that's fine. But start thinking about the idea that you're going to take each of those terms and divide by the common factor. 4y divided by y is 4. Negative y squared divided by y is negative y. And if it's just developing for you, if you're just sort of going, I'm just starting to get the feel for this, that's fine. That's why there's so many. You know it's a repetitive lesson when you see 9 examples immediately. Like, lots of time to go, okay, I'm starting to get what's going on here. Okay, coefficients first. Breaking this procedure down. Look at the coefficients, and is there a number that divides into both 4 and into 3? No number that you could bring out. And I'm going to do one in red, and then I'm going to do one in blue. There's another way to answer this question. What about x's? Is there x's common to both? There is x's common to both. What's the most number of x's I can take out? 1. So I bring out the x in front. And then I just divide the x out of both of those and say, okay, negative 4x, divide out the x is negative 4. 3x squared, divide out the x, I get 3x. But some of you might use trial and error. I know. You'll be just like, let me just write down what goes in the brackets here so that when I multiply it out, I get what I started with. Now, if you're right with me, you might be like, why didn't you pull the negative out there? Some people might answer this question like this instead. And I like that answer too. Okay? Let's not get too freaked out about the negative. until it starts to matter. Very soon it'll start to matter, and you'll see why when that happens. So for now, I mention it, but let's not get derailed by the negative at this point. Well, this is the first one that makes you do everything. 3x squared plus 6x. Coefficients first. Is there a number that divides into both 3 and 6? 3 divides into both 3 and into 6, so I'm bringing that out. Then I look at the x squared and the x. Do they both have an x that can be pulled out? Yeah, just one. That's the most that can be pulled out of this. Like, is there one where you get to pull out more than one? Yeah, coming up in I here. We'll see how many we can pull out. Then, what goes in the brackets? X plus. I agree with x, because 3x times x is 3x squared. And then plus 2. And the way he said that is fine. That you're doing the right things and you go, oh, 3. Oh, wait, no, 3, that's not right. 2, yeah. There's a bit of a trial and error to this, and that's correct. You're doing it right when you have to go, let me just check these things. But if you want a systematic procedure, you divide. You go 3x squared divided by 3x is x. 6x divided by 3x is 2. That's the procedure for those of you who want a way to just get the numbers. How about this one? A little more challenging on the numbers. There's lots of numbers that divide into 24 and 16. What's the biggest number that divides into 24 and 16? 8. How did you get it? Yeah, I know. Some of you mental math is such that you'll just look and go, 24 and 16, wait, these ring a bell. Those are multiples of 8. Yeah, and you'll just know. Let's do one where you don't get the full common factor. Let's say you looked at it and you said 4. Okay? We'll do it, quote, wrong and see if we can recover. We can. So let's say I went after 4. If I went after 4, I would have got 6m squared minus 4. Then I look and go, wait a minute. There's still a number that divides into 6 and 4. I must not have taken the biggest number because I can still take a 2 out of those. You can go back to the beginning and go, okay, I'll take out 8. Or you can also do this. You can go, okay, 4 and then take out a 2. I don't know why I wrote x there. Maybe I'm so used to writing x. And then multiply the 4 and 2 together. Do I suggest that procedure? Well, no, but I wanted you to see it to see that you can recover if you don't get the whole thing. Reminds me of reducing fractions, right? Maybe they give you this fraction to reduce. They give you 20 over 40. Some people might see, oh, that's a half. Somebody else might go, oh, well, I can divide them both by 10. That's 2 quarters. And then they go, oh, it'll also divide by 2. That's 1/2. So reducing fractions doesn't have to be an all in one step, and common factoring doesn't have to be all in one step either. You make your life easier if you find the biggest number, though, right off the bat. Question? Say it again. That would be factored. It wouldn't be fully factored. By fully factored, we're taking the most out we can get. And if there's still a 3 that could be taken out of both, we should have got that 3 as well. So you're saying, oops. What happens if I do this, and I'll do it in blue? What happens if I had gone x bracket 3x plus 6? Then you look at it and go, oh, what about the numbers? Is there a number that divides into both 3 and 6? And you go, yes, there is a number. So I'll bring a 3 out as well. And now it's fully factored. I've brought out as much as I can out of the common factor because 3 divides into both of those. Okay? Well, here it is, the big one for this page. 12 is the number that divides into 12, 24, and 48. But again, if your mental math, if it doesn't just come like this, then you have to play with the calculator a little bit. You'd be like, let me keep checking numbers and see which one works. And hopefully, actually, that'll help you with your mental math. The more of these you do, the better your mental math will become. How about the y's? What's the biggest exponent of y I can pull out? And I've changed the phrasing there a little bit to try to help you. The biggest exponent of y is? y2. I see the biggest exponent is 4, but the most that's common to all is 2. Then, this is the first one I'm going to try and pressure you. into using division to get these. 12y fourth divided by 12y squared. 12s are gone. I get y squared. Negative 24y squared, divide by 12y squared, I get negative 2. And 48y cubed divided by 12y squared, I get a 4y. I am not claiming that's easy. I'm trying to look at it and go, here are the steps to this. Decide on the number that comes out, decide on the variable that comes out, and divide them all out. Yes, factor it as fully as possible. And right now it's like, well, why? Why do you care about the simplest? You're going to see when we go to do more quadratics that we're going to want the simplest we can in the brackets. That's going to make our life the easiest. So by doing a little bit more work here to get the biggest out, we're going to save ourselves a lot of work in other areas of the math in this chapter. Okay. Other questions? Okay. That's really the end of the lesson. What I'm going to show you next is going to help us in future lessons, okay? So do not let this freak you out. Just look at it and go, oh, this is kind of interesting. This will get us ready for some tougher lessons. Look at those two terms, and I'm going to underline each of the two terms here. Do you see anything that is common to both sets? The brackets. Yeah, that was my favorite answer. I heard people say 3, I heard people say x, I heard someone say x plus 3, but I heard the brackets. Look, the brackets is common to both. So weirdly, we can use what we've been doing to say, well, that means there was an x plus 3 out front of this. X plus 3 got multiplied by each of these things. And before you freak out, go, okay, so now in the brackets, I'll divide x plus 3 by each of those. That means I'll just take it out of each of those, and I end up with 5x minus 2. Now, the first time you see that, it's okay if that's like, what are you doing? Because it's like one too many letters and numbers the first time you see it. But I'm just doing what I did before, is I looked and I said, well, what's common to both? Put it out front. And the x plus 3 was what common to both. Remember what I said. The previous page is really today's lesson. This is just like me getting ready for the tough stuff that's coming up in how many lessons? We do this one. Then the next lesson, you'll think it's pretty easy. It's the lesson after that that people often find a little bit difficult. And this is getting ready for that. Question? No. Okay, you figured it out. Good. Well, all right. Maybe the first one is like, I don't get it at all. Maybe we need a second one before we get it. When you look at these two expressions, 3x bracket 2x plus 1, and 4 bracket 2x plus 1, and me saying it out loud is a monstrous hint, do you see anything that is common to both, that is in both terms? 2x plus 1. So that's what comes out front. That's what was in both terms. Now, what was left? If I take 2x plus 1 out of that first term, what's left? 3x is in the first term and 4 is in the second one. And after you see it a couple times, you're like, okay, I just have to think differently. I have to look at the bracket as what's coming out front. I am not claiming that's easy. I'm not going, oh, so see, no problem. There you go. I'm seeing some frowns, which is good. You should be like, whoa, this algebra is going to get heavy. Oh boy, is it going to get heavy. Yes, algebra is going to go nuts here. Not in grade 10 as much. We'll delve into it, but in grade 11, it's certainly algebra is going to go wild. Yeah? I have some good advice for you. Any algebraic homework from here on in, no matter how good you are at it, do it all. Yes? Don't play around anymore with this idea like, oh, I get it, I'll be fine. Algebra is about practice. It's like shooting baskets. If you watched me, if you came and LeBron came to your gym class and said, here, like this, and showed you how, you wouldn't look at that and go, good, I'm a great basketball player now. You'd go, okay, let me try it now 100 times. I'm not saying I'm the LeBron James of mathematics. That's not what I'm saying. I'm saying that practice wins here. Practice wins. Everything else loses. Yes? Any questions, though, on those two very tough examples? No, actually. What we're trying to do is get less multiplied out. We want the factored forms. We got a taste of that last chapter. When the quadratics were factored, we got a lot of information from that. We're going to be happier in factored form, and that's going to be true from now until the end of calculus. We'll be happier when it's in factored form than in expanded form. We'll get more information from the factored form than from the expanded form.
What is calculus?
Calculus is actually it's a short form for calculate, basically. And calculus teaches you how to calculate things that right now it would seem impossible that we could calculate them. And during that course, you'll find out like, oh, using this particular method, we can calculate that. Sort of like what we're doing here. We're like, there's no way for me to know when I first look at this what the factors of this are. But now we're learning how to calculate it. There's methods that we can use to calculate it. And so calculus will go a lot farther with that. Yeah. Great question. All right. I believe there's one more page to go. One more page for mine. When there are 4 terms, this is the next step in that, look at each pair and see, is there something common to each pair, and then see what happens. Is there something common to ax minus ay? Is there, yeah, what's common to both? What's in both ax and in ay? A. So I common factor out the a. So my question is, if I take the a out of only the first 2 terms, what was in the brackets? Oh, I'm not looking at this one yet. Yeah, but you're right. I'll get to that one in a second. I'm just looking right here. Those 2 terms, x minus y, was in that first bracket. You're like, oh, you're breaking them into 2s now? Yeah. When there's 4 terms, we usually break them into 2 sets. So what is common to 5x minus 5y? Me saying it out loud just seems to... 5, yeah. So what was in that bracket after I took out the 5? X minus y. Now look. Is there anything common to both those terms? I've got a bracket x minus y and 5 bracket x minus y. What's common to both?
The bracket x minus y.
The bracket x minus y is common to both. Whoa. I'm on my way to something bigger, by the way. Next Monday's lesson. You'll be happy that we dipped our toe in this very tough stuff and went, do I get it? I don't know if I really get it. But when I reteach it again on Monday, things will go better. So if I take x minus y out of both brackets, the other one is a plus 5. That's what's left of each of the terms. Let's try it again on a really ridiculous one. I really went nuts here. I like the double underline move here. I used a curly underline for the first 2 and a straight underline for the second 2. And now here I go. What divides into both 12 and into 2? 2. How many x's can I take? There's x cubed and x squared. 2. I can take degree 2 out of there. This one's degree 3, this one's degree 2. I can take 2 of those. Okay. I'm really reaching here now, though. What will be in that bracket if I take 2x out of those first 2 terms? 6x, good. Plus 1. He sort of said it was surprised. Plus 1. Yeah, sometimes it's just a 1. Now, what number divides into both negative 30 and negative 5? Negative 5. Take the negative. If the first one's got a negative, take the negative. If I take negative 5 out of both those, 6x plus 1. Whoa. It did it again. What's common to both of those terms? 6x plus 1. And just to check, is there anyone who can tell me, once you've seen enough of these, it's not all that surprising. What does the second bracket have to be? 2x squared minus 5. Those are not easy, friends. Cancel your date for Thursday night or whatever you got going on and go, Thursday night's algebra night. Text your mom right now, your dad, uncle, aunt, grandma, whoever, and say, order pizza right now for Thursday night. We're having pizza algebra night. Yeah? I come out of my test on Thursday, and then I am going to algebra. We need this. We need this. I'd argue it might be the most important topic I've taught so far. Might be. That homework's Thursday, especially if you've got a lot of other stuff to do to get ready for the test, okay?